the most effective way to approach a question on an exam, the first thing to do is read the question and try to really understand the question. So by understanding, it's not just reading through it to get the information, but reading through it, and as you read through it, you write the information that is needed down. You kind of like separate the chaff, the unnecessary information from the real information that you need to get your answer. So what I usually do during an exam is I write data, which is I write data. It means I'm going to get the data that I need for the question, for my my solution. So then I go on to read the question. So it says, if the x component of the electric field in the origin is given by Ex, so this is given x, the s component of the electric field as a function of x. So we write it down. Oh, okay. The electric field of x is a function of x. Okay, so that's what we have. Write it down. Okay. So what else? And this is x is in meters. So alright, s is in meters. So one thing you should know is whenever you're solving a question, you should try to change all the units to the SI unit. It makes your life easier, basically. And then it goes on the next line. It says, and its y component is this. And as you can see, the y component of the electric field is a constant. It's just 2. So which means that the y component of this electric field is constant. In other words, it's uniform. So, and then it says that if the potential at the origin, the potential energy at the origin is V origin. So the potential energy at the origin is V origin. So you can like write down all the information that you need under the data. And then that also helps you really understand the question. And then the potential at the coordinate 3, 6 is VP. So at the coordinate 3, 6 is VP. I'm going to omit the meters because it's just a unit. So make my life easier. I'm just going to get rid of it. So now the question says, what is VP minus V origin? So you notice that instead of the question saying find the change in potential energy, it gives you the formula for potential energy. So this is kind of like what I was saying, like try to really understand the question instead of going by the normal way and say find the change in potential energy. It says VP minus V origin. So it's kind of the same thing, but if you really don't understand the material, it can confuse you. So that is it. So now we have our data down. We can go ahead and start answering the question. So one thing also that you really have to do, I call it homework, is you really have to understand the material that you're doing. Even if you get the material, the information out of the question and you really don't know anything about the topic, you can't do it. So you have to understand it. So by understanding it, it's in any way that you can. So here we have formula. This is my formula sheet, and you can see that we have formulas to find a change in potential energy. And as you can see, the change in potential energy for a non-uniform electric field, you have to find the integral of the electric field over that specific distance that you want to find a change in potential energy. But if you have a uniform electric field, then you can just multiply the electric field by the distance. So we can use because y is constant, it means it has a uniform electric field. We can just use this second formula for it, and it will make our life easier. But the first one is not. It is not constant. It varies as goes on. So we have to use the integrand. So as you can see, it's a negative derivative. So let's go on and try to solve it. So a change in velocity. Let's do x first, since it's a little bit difficult because we have to find integrand. So let's do that one first. So the change in potential energy on the x for the s component will be, it will be the negative derivative from 0 to 3, because we are finding the potential difference at 3, which is the s coordinate. So from 0 to 3 of the electric field, and the electric field as given to us is 1. We don't have to write a unit, so we can just we can write a 1 if you want to, but it's really not necessary. X squared dx. So I don't know if you've taken a calc class before, but this is a very simple integration. So you just add 1 to the exponent and divide it by whatever you get from that. So 2 plus 1 is 3 divided by 3. So we're looking for it at 3, 0. So then the answer becomes 3 cubed divided by 3 minus is 0. So if you put in 0, you get 0. So you don't have to write that. So then the final answer for the change in voltage in the x-axis is -9, because it's the negative derivative of it. So it's -9. Because the 3 cancels 1, so 3 cubed is 9. Now let's look for the change in voltage in the y-axis. So now, since the change in the electric field in the y-axis is constant, we can use the second formula, which is pretty simple. It's just the electric field times the distance. So the electric field, which is 2, let me write the formula first. Electric field times the distance. So the electric field, which is 2, as given in the question and as we wrote in our data.